launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 4 minutes and holding. This planned 30-minute hold allows launch conductor Scott Barney and his team time to conduct final systems checks and resolve outstanding issues prior to entering the terminal count. Today's 18-minute launch window opens at 11:36 a.m. Eastern Time. Good morning, and welcome to Mission Control here at the Atlas Spaceflight Operations Center. My name is Steve Agate, and I'll be your commentator for today's flight. GPS IIF-10's delivery on orbit is scheduled to take place about 3 hours, 23 minutes after liftoff, and because of that long duration, we'll conclude our live coverage about 20 minutes after launch. However, before we sign off, Lieutenant Elaine Sotikun from the Air Force's GPS Directorate will join me here in Florida to discuss the GPS system and a very important GPS milestone. As I just mentioned, Atlas V is launching the 10th satellite in the Air Force's Global Positioning System 2F constellation and the second of 3 planned GPS satellite launches this year. GPS is celebrating an important anniversary in a couple of days, and we'll have more about that later in today's show. GPS, or Global Positioning System, is a space-based positioning system consisting of a minimum of a 24-satellite constellation, providing navigation and timing information to military and civilian users worldwide. The signals are so accurate that time can be measured to within a millionth of a second, velocity within a fraction of a mile per hour, and location to within a meter. Built by Boeing, the next generation 2F series provides improved capabilities for military and civil users and a new third civil signal, L5, for commercial aviation and safety of life applications. On June 30th, GPS IIF-10 was encapsulated inside the payload fairing, and on July 6th, the encapsulated payload fairing was transported to the Vertical Integration Facility, or VIF, and made it to the Atlas V. The VIF is located approximately a quarter of a mile south of the launch pad. Then, yesterday morning, the fully integrated Atlas V on its mobile launch platform was rolled from the VIF to the pad at Space Launch Complex 41. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a trip that takes about 30 minutes to complete. Once the mobile launch platform reaches its park position at the pad, the team conducts final securing. Following pad clear about 4 hours before launch, the Atlas V is fueled and configured for launch. The Atlas V rocket stands 189 feet tall, or about 19 stories, and weighs more than 700,000 pounds fully fueled. To lift the Atlas V away from the pad, approximately 860,000 pounds of thrust is produced by the RD-180 engine. Using approximate times.
5, 4, 3, 2, 1, 0, and liftoff of the Atlas V rocket.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 78 seconds. At 90 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour, and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Cutoff of the Centaur main engine follows an approximately 13-minute burn. The mission now enters a 3-hour coast phase. At 3 hours 17 minutes into the flight, the Centaur main engine is started for a second and final burn. This burn will last approximately a minute and a half. Following the second Centaur main engine cutoff, the mission enters a final 5-minute coast phase. At 3 hours 23 minutes, Centaur releases the GPS satellite for the United States Air Force. This is Atlas Mission Control at T-minus 4 minutes and holding. Today's flight is the 58th launch of an operational GPS satellite since the first satellite lifted off on February 14, 1989, riding atop the inaugural Delta II rocket. Over a span of 20 years, ULA's Delta II launch vehicle delivered the first 48 Global Positioning System satellites to orbit. With the debut of the 2F series, the next generation of GPS satellites, ULA's larger and more powerful Delta IV and Atlas V evolved expendable launch vehicles, were called into service. To date, 6 GPS 2F satellites have been launched on Delta IV launch vehicles and 3 on Atlas V launch vehicles, demonstrating the mission capability and manifest flexibility that ULA provides.
OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
This is Atlas Mission Control at T-minus 4 minutes and holding. In a few moments, launch conductor Scott Barney will poll the team for the final go to pick up the countdown. 27 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge systems, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical systems, airborne.
Go.
Ground.
Go. Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ACS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
ACs go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. Timer T0 is planned for 15:36:00 Zulu. Set the count to start at 15:32:00 Zulu.
Roger. T0 is set for...
Polling is complete and the team has been given the go for launch. The countdown will resume in approximately 2 minutes. From T-minus 4 minutes until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team confirm securing of Atlas LO2 topping, followed by the call to transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures. A final status check of Atlas, Centaur, and GPS IIF readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engine ignites and performs a health check, followed by ignition, to lift the vehicle off the pad. After liftoff, you'll hear the voice of Marty Malinowski, providing launch vehicle ascent data.
Valves locked. 60.
T-minus 1 minute and counting.
Range green.
Stable at step 3.
T-minus 30 seconds and counting.
25.
Status check.
Go Atlas.
Go Centaur. Go GPS.
20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 10th GPS IIF satellite for the United States Air Force.
Body rates look good.
You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
RD-180s continue to perform well. Injector pressures are in band. PU is controlling nominally. Minor attitude rates at this point. HER roll program has completed. Vehicle body rates are controlling right down the middle. Approaching supersonic speed. Body rates continue to look good. Mach 1. RD-180 performance continues to look very good at this point. Injector pressures, pump speeds, all within band. Max Q. Body rates continue to look good. Booster has throttled back, right on schedule. Engine response looks good. Current altitude is 10 miles. Downrange distance is 4.5 miles. Current velocity is 1,840 miles per hour. Booster engine performance continues to look very good at this point. Body rates controlling down the middle. Bus and battery voltages are stable. Tank pressures look good. Coming up on closed loop steering. And we have begun Q alpha limited steering. Vehicle response looks good. Engines continue to perform nominally. And we have fired the fire isolation valve. That system is now pressurizing the RCS to flight pressures. Response looks good. Booster engine continues to perform well. Pump speeds and injector pressures are in band. And we've completed the Q alpha limited steering. Body rates continue to control well down the middle. Booster has throttled back. Engine performance looks good in response to the throttle command. Currently accelerating at 4.7 Gs. Coming up on our 5G throttle segment. And booster has begun to throttle. to maintain a 5G acceleration level. Boost phase cooldown is underway. And we've now begun to throttle to maintain 4.6 Gs. Boost phase chill down is complete. Coming up on BECO, and we have BECO. Engine shutdown looks good. We have retros and stage separation. Looks like a clean sep. We have LOX and fuel pre-start on the RL-10. The GN2 purge variant of the RCS is underway. We have ignition and full thrust on the RL-10. We have indication of payload fairing jettison. Looks like a clean sep. Centaur steering has been enabled. Small body rates correcting out attitude errors. LOX tank pressures have vented down as expected. Storage bottle pressures look good. Bus and battery voltages are stable.
The Global Positioning System is a marvel of the modern age. It consists of more than 30 GPS satellites circling the globe over 12,000 miles above us. In tightly controlled orbits, these U.S. Air Force satellites continuously transmit their signals to Earth. An extraordinary technology, GPS enables anyone with a GPS receiver to determine their precise location and the exact time anywhere in the world, usually within a meter and within a billionth of a second.
GPS is ubiquitous. It's everywhere. It's in our cars. It's in devices that you use to determine how far you've run or ridden your bicycle.
With billions of users and countless devices, it is easy to take GPS for granted. But it is the essential platform for innovations which enables us to do everyday things like buying gas at the pump and getting directions. And amazing things like tracking ice melts and saving lives in ways that were formerly impossible.
The beauty of the GPS system is that it's available for everyone. The cost of entry for any user is simply the cost of their receiver.
Boeing helped make GPS possible. It's been the U.S. Air Force's prime contractor on 4 major programs, replacing the initial group of satellites as their service lives were completed. Overall, Boeing has produced 2/3 of all GPS satellites, more than 40 in all.
Satellites are normally built in a low volume, perhaps 2 or 3 at most. And they're usually sit in one spot, and resources are brought to the satellite.
Now, to ensure that GPS is available whenever it's needed, Boeing has changed how satellites are made. It's producing 12 new GPS satellites using a streamlined process based on its efficient and advanced airplane assembly line techniques.
Our goal is to have the highest quality.
These new satellites bring next-generation performance to the GPS constellation we all use every day. As a result, they are delivering new levels of accuracy to what is already a remarkably accurate system, and they are being built in a much more efficient way, ensuring that this essential technology is available when we need it.
Line temperatures are good. Tank pressures are stable. Storage bottles look good. Centaur is currently flying at an altitude of 229 miles, downrange distance 2,129, current velocity 15,980
This
miles.
is Atlas Mission Control at T plus 12 minutes, 13 minutes, 1 second of the flight, and all systems continue to operate as expected. The Atlas Centaur second stage and GPS satellite are currently located over the North Atlantic Ocean, southeast of Greenland. Our next event, the first Centaur main engine cutoff, or MECO 1, is scheduled to take place about 4 minutes from now. Here's Marty Malinowski.
And Centaur has IIP vanish. At this point is now orbital. Current altitude 206 miles. Downrange distance 2,591 miles. Velocity 17,576 miles per hour. RL-10 continues to operate well. Chamber pressures, box pump discharge, and fuel venturi all look good. Minutes. To MECO. Tank pressures continue to remain stable. Storage bottle pressures look good. Body rates are controlling right down the middle. And continuing to see our thermal conditioning firings at the expected intervals. One minute to MECO. Centaur engines continue to look good. Tank pressures and storage bottles are stable as well. PU is controlling near nominal. And Centaur PU has been commanded to fixed angles. Preparation for MECO. And we have shutdown. Engine shutdown looks good. We have 4S settling motors on.
This is Atlas Mission Control at T plus 17 minutes, 27 seconds into the flight. Marty Malinowski just confirmed MECO 1, or cutoff of the Centaur RL-10C engine. The mission has now entered an extended coast phase, which will last about 3 hours. Following MECO 1, the mission trajectory changes to a southeasterly heading, flying over Eastern Europe, Turkey, and Saudi Arabia. It will continue in a south-southeasterly direction over the Indian Ocean. Following a short second burn of the RL-10C engine, Centaur will deliver the GPS IIF-10 satellite to semi-synchronous orbit over the southern Indian Ocean south of Australia. Separation will take place about 3 hours 23 minutes after liftoff. Due to the long duration of today's mission, we'll conclude our live coverage in a few minutes. But before we sign off, Lieutenant Sodikun, we have an important anniversary to recognize.
Yes, Steve, we do. After the GPS constellation achieved initial operating capability in 1993, the Air Force deployed 24 satellites and 6 orbital planes around the Earth. In 1995, after completing all system tests, the Air Force declared full operational capability on July 17, 1995. The Air Force officially published an announcement on this momentous achievement, signifying the culmination of 20 years of research, development, and implementation that led to this revolutionary navigation system. Over the last 20 years, GPS has become an integral part of technology that affects the lives of billions of people around the globe.